When Japan's Hayabusa2 spacecraft touched down on asteroid Ryugu, the world watched with excitement. But what it brought back was far more than dust and rock. Hidden within the samples was something so unexpected, so potentially groundbreaking, that it nearly unraveled the mission itself. At first, it seemed like a triumph, proof that humanity could reach a tiny, distant space rock, collect material, and return it to Earth. But no one could have imagined what Hayabusa2 would actually discover. It wasn't just lifeless carbon compounds or dead rock chemistry. They were structures, complex organic compounds organized in a way that hinted at something more, something possibly alive. Hayabusa2 launched in December 2014, sent on a 6-year voyage to the asteroid Ryugu, a carbon-rich, spinning top-shaped rock about 900 meters in diameter. Ryugu is what scientists call a C-type asteroid, meaning it's loaded with carbon compounds and is considered a time capsule from the early solar system. It orbits the Sun between Earth and Mars, and because it hasn't been geologically active like a planet, its surface might hold the original ingredients that built our solar system and maybe even the origins of life. That's why the Japan Aerospace Exploration Agency, or JAXA, chose it. But no one could have anticipated what would really be found buried in that black rubble. In 2019, after years of travel, Hayabusa2 successfully fired a small impactor into the surface of Ryugu, blasted a crater, and descended to collect the freshly exposed material. The feat itself was like threading a needle while blindfolded in a wind tunnel and insane technical ballet in zero gravity. But it worked. Hayabusa2 grabbed its samples and started the long journey back. When its sample capsule re-entered Earth's atmosphere in December 2020 and landed in the Australian outback, scientists rushed to open it. What they saw stunned them. Not only did they find amino acids, some of the key building blocks of life, but they also found something that sent shockwaves through the scientific community. Microscopic organic structures, highly complex and oddly arranged, were detected in some of the Ryugu dust. These weren't just random molecules. Some looked like they had been selectively formed. What made things more terrifying was that the equipment meant to contain the samples began showing strange readings. Slight chemical reactions, traces of gas that weren't expected. Instruments showed low-level activity, biochemical, perhaps reacting to the environment around them. At first, scientists assumed contamination from Earth. But then, multiple labs confirmed it. The reactions had started before Earth exposure. That meant they were happening in the sealed capsule. Something in that asteroid sample might have been alive, or at least reactive in a way similar to life. Panic wasn't the official response, but it was definitely the feeling in some circles. The containment protocols weren't designed for alien biology. What if they had just delivered a Trojan horse of extraterrestrial microbes into Earth's atmosphere? The sample was triple contained, but it wasn't under full quarantine like samples from a known biohazard. JAXA and its scientific partners quickly moved the samples to biosafety level environments. NASA scientists, already collaborating with the Japanese team, issued quiet internal alerts to monitor for any bioactivity. But here's where it gets stranger. Some researchers began reporting degradation of nearby biological samples stored in the same facilities, DNA breakage, altered protein structures. Was it just coincidence, radiation, or was something from Ryugu interacting in ways Earth-based science couldn't explain? The teams initiated multiple containment tests. Nothing spread, no outbreak, no radiation spikes. But one thing became clear: these weren't just lifeless molecules. As the analysis deepened, scientists found dozens of amino acids not previously seen in meteorites, complex hydrocarbons that suggested a form of autocatalysis, molecules organizing themselves into more efficient patterns. Some researchers quietly began using the phrase pre-life activity. Ryugu, it seemed, hadn't just held onto the early solar system's chemistry. It had maybe incubated the very first steps of life 4.5 billion years ago. And now, that chemistry was in our labs. The implications were massive. If life's building blocks existed and evolved on a random asteroid like Ryugu, then the odds that life exists elsewhere skyrocketed. We might not be the result of a rare Earth miracle. We might be just one of countless biological offshoots across the galaxy, each birthed from asteroids just like Ryugu. But for the mission itself, this was both thrilling and terrifying, because the protocols in place for sample retrieval were not designed for biological material. If even one microscopic structure had proven to be infectious, the mission could have turned catastrophic. JAXA narrowly avoided a global incident by pure luck or perhaps by the robustness of their engineering. Today, the Hayabusa2 samples remain under strict watch, and though nothing dangerous has emerged, the haunting possibility remains. We may have brought back not just the past but a fragment of a long-lost biological process from deep space. Mission was hailed a success, but deep inside that capsule, beneath the grains of asteroid dust, may lie the most important and dangerous discovery humanity has ever made. And if that discovery wakes up, what then? If this story fascinated you as much as it did us, smash the like button, share it with someone curious about life beyond Earth, and subscribe to Beyond Stars for more shocking space revelations every single week.